going to have a look at the question from last year's paper. So the first question, question 4, is prove that cosec 2 theta minus cot 2 theta equals tan theta. First thing, the angles don't match, so I'm going to have to use double angle formula at some stage in this question. I would start off with the left hand side, write this as 1 over sine minus cos over sine. The bottoms are the same, so you can just subtract the tops. 1 minus cos 2 theta over sine 2 theta. Now I'm going to deal with the double angles. For the cos double angle, I've got a choice of formula. I'm going to use the one that is 1 minus 2 sine squared theta, and the reason being the ones will cancel off. Sine 2 theta only has one choice, it's 2 sine theta cos theta. For the top line now becomes 1 minus 1, which is gone, minus minus, which is positive, 2 sine squared over 2 sine theta cos theta. The 2's cancel, sines cancel, leaving you a sine over a cos, because that was a sine squared on top, which is tan theta, which is the left-hand side. Sorry, the right-hand side. So you have proved that. Part 2 of this question is hence. When you see the word hence, you use the previous answer. So, hence find tan pi over 8. So if you look back up to the top, tan theta, I can rewrite that as cosec 2 theta, so 2 pi over 8 minus cot 2 theta, 2 pi over 8. Cosec is 1 over sine, that cancels down to pi over 4. Cot is 1 over tan, which cancels down to pi over 4. Sine pi over 4 is 1 over 2. Tan pi over 4 is 1. So 1 over a fraction turns it upside down, root 2 minus 1. Now I've also got to do question 6 from this paper. We scroll down to it. Question 6. This expression can be written in the form of r sine. So we'll work that out first of all. So question 6, part 1. So we were given 8 sine x plus 15 cos x, and that is to be written in the form of r sine x plus alpha. So you expand out this side, so it's sine x cos alpha minus cos x sine alpha, and then you equate the sine axis. So you've got 8 here on this side equals r cos on this side, and then do the same for the cos's. You've got 15 on this side, and over on this side it's, sorry, it should be a plus, r sine alpha. Equation 1 and equation 2. If you put equation 2 over equation 1, you get r sine alpha over r cos alpha equals 15 over 8. R's cancel, sine over cos is tan, so 15 over 8, and do inverse tan for that to give you alpha to be 61.9 degrees. Then if you do the standard practice, 1 squared plus 2 squared. So you square this, 8 squared add 15 squared. You don't have to go through the whole rigmarole for that. You're okay just to write r squared. Be careful not to write 2r squared in that. It's just the r squared because it factorizes out. And then if you work that out, 8 squared plus 15 squared, and then square root it, you'll get r to be 17. So basically the expression 8 sine x plus 15 cos x can be written as r sine x plus your alpha. Part 2 of that question, and I scroll down to find it. Hence or otherwise, so hence when using the previous answer, determine the maximum value of this. So I have got 18 over 8 sine x plus 15 cos x plus 23. Now this is part 1, so I'm just going to sub in my answer there. So that becomes 17 sine x plus 61.9 add 23. So I want this to be as max as possible. For it to be as max as possible, I will take the 18 and I will divide it by the smallest bottom number I can. I want the bottom line to be as small as possible. So I'm going to consider this section here, 17 sine x adds 61.9, and I want that to be a minimum. Think of your ordinary sine graph. The lowest value that can be is -1. So the minimum that can be is -17. So the minimum value of this expression is 18 over -17 plus 23. So 18 over 6, which gives you 3. The question said when. So normally, your minimum over here is when x equals 270. But your graph has been, you do the opposite, move it back 61.9. Start with the 270 and move it back 61.9. So x is 208 degrees. Try to remember to give your answer to 3 significant figures.